Okay, so guys, welcome back. So we're pretty much doing the same thing as we did like yesterday. Um, those questions that Black Pen Red Pen gave in his videos, singular, from his visit to Princeton University. So yeah, we'll be having a look at those questions. Just give me a minute. There you go. Yeah. So, okay, the first one I did in yesterday's video, it was, well, honestly pretty shabby because like my parents were home and there was a lot of noise. I had like 3 cuts in between, but yeah, anyways, I just wanted to upload it quick. So the second one, I'm home alone right now, so yeah, I think I'll be fine for the next around about 40 minutes. Yeah, so anyways, there's no interruptions in this one. There's good volume in this one, so yeah, don't click off if you clicked off in the last one for that reason, for those reasons. Anyways, so yeah, this is the second question. I guess I should do like a 2 there. I didn't do a 1 there because I was in a hurry. So yeah, this is the second question that Black and Red Pen gave from the Princeton Math Competition Olympiad something. It was something related to Princeton University because clickbait. Yeah, kidding. Anyways, so yeah, we have a function given f of x, x squared plus 4x plus 2, and then we have the difference of the largest value of f4 of x. Okay, so let me just define fn of x first. So fn of x is equal to f of f of f of dot x. You should have those dots there technically, but yeah, I guess people tend to forget them. Anyways, so yeah, that's fn of x is defined as this thing. I think like okay, so we'll define f of x. Okay, so we'll have an n number of f's, right? N times iterated, I guess I should say iterated. Yes, I can speak English. Okay, so iterated n times, right? So that's how we're defining this weird notation. Anyways, that's just to get the notation out of the way. So yeah, we've been given the difference of the largest value of f4 of x minus the smallest value of f4 of x. So it's like the maximum value and the smallest value. I should mention these are like element of the real numbers. Yeah, I think they were like both positive and negative, but maybe just anyways, it doesn't matter. Yeah, so I've got that in. Then well, I mean, that's just something I said, right? For some reason, why the hell did I say that? That's weird. Yeah, wait. Okay, so anyways, f4 of x is 0. Yes, we'll find out later. And we've been given that r is the r, like this difference is in the form a to the p upon q. So it's like, let me just write it in a bigger form here, a p upon q. Yeah, so that's how it is. And we have to find the value of a plus p plus q. There's a few conditions given for like a, p and q. Like p and q are co-prime, a square free. Anyways, so those are like nitpicky things. So anyways, let's just get this out of the way first, right? What is this monstrosity? See, what is f of x? So first we'll say like f of x is, say, ax plus b, right? So we'll define f of x as, let me just rub this one off because, you know, disgusting. Anyways, yeah, f of x. So that's like, we have f, right, evaluated at something. So that something is going to be of the form a plus b, but see, our x here is f of x in this case. So we have a times f of x plus b. So we have a times, and we have f of x here, so ax plus b. So it's like a square x plus ab plus b, maybe. Is that math? Yes, that's math. Okay. Yeah, that's cool. Anyway, So that's how like these things work, right? So anyways, this question is mostly about finding a pattern for like fn of x, right? So okay, let's start it, I guess. So first we'll start by, f of x is equal to x square plus 4x plus 2. So let's think about it, right? What will be useful for us? And after some thinking, you'll realize that we have to like in some way factorize it. So well, I mean, using the quadratic formula is just overkill. Using like splitting the middle term method is fine, but it's not that great. So yeah, here we'll use completing the square. You'll realize it after some tries. You can try the other methods, but they won't, yield a result as quick as this one. So, let's try completing the square. So x square plus 4x plus 2. Why did I write that again? Well, I did anyways. So, what you can do about it? So anyways, we have a 2 here, right? Okay, so let's just write that as 2 times 2 times x, right? So we already have an x squared here, right? So this x and this x, they're the same thing. Then we have a 2 here. Okay, that's pretty neat. But then we have a 2 here, but we only have a 2 here. We should have 4 here. Just call this 4, but then we'll have to subtract 4, right? I'm just gonna put that in a bracket, kind of. And then we have a plus 2 at the end, this one that's lagging behind. So anyways, this is quite clearly a perfect square, x plus 2 whole square, if you've ever like done any math in your life. And this is minus 2 if you've even passed nursery. So okay, yeah, that's f of x in a more useful form, and we'll see how that's useful in about a second. So well, let's try f of x, which by the way we've defined as f2 of x. Yeah, so anyways, here we'll have, okay, so in place of x we'll put f of x, and f of x is that. So we have something plus 2 minus 2. Now that something is f of x, but f of x is x plus 2, oh, and something squared, sorry, minus 2, right? And that's, well, as you can see, that's pretty neat, so these two cancel out at just a 0, so it's just x plus 2 to the 4th minus 2. Yeah, pretty cool. Now I think you see the pattern, right? This is to the second power, this is to the 4th power. Let's do another iteration. So we have f3 of x. So we had f square that, so f square, I'm saying f2, I should say. Yeah, so it's like f of f2 of x, right? F of f2 of x, let's just write that, and that will be, well, let's think about this. So we're putting in this term into an expression which is of this form, but instead of x we have f2 of x. So let's just leave some space, then plus 2, that thing squared, minus 2, and here again, if you've noticed the pattern at all, x plus 2 to the 4th minus 2. Now these two again cancel out, and I think the pattern is quite evident now, minus 2. This is just by exponent rules. So let's just write it in a box here. X to the a over to the b is equal to x, well, that's great, x to the a b, right? That's like something we're using here. So yeah, anyways, that's f3 of x, and by now you should have observed the pattern. So here we have a 2, here we have 4, here we have an 8. So having an 8 there, and that should be something that should click to your brain. 2, 4, 8. Where have I seen that? Well, that's simply 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. And see, these are 1, 2, 3. So the exponents are like in a sequence, and therefore we can say that f4 of x, instead of like writing out all of this stuff, well, I mean, let's just write it for fn of x, shall we? So fn of x is x plus 2 to the this is 2, right, to the 2 to the n. Yeah, right. And then of course a minus 2, I should say minus 2, and that's fn of x. So quite evident that f4 of x would be x plus 2 to the 16 minus 2, right, because 2 to the 4 is 16. I think you should know that, I'm assuming. And okay, so I finally figured out why I wrote this. It's because we need to find solutions to this when it's equal to 0. So yeah, yes, I clicked, my memory clicked. So basically we've got this equation, and we've got f4 of x is 0, and we have to find real solutions. Yeah, I forgot to write that at first, but you know what, we got that now. So let's clean up and yeah, let's see where this stuff takes us. Okay, so we were here last time we left, and then there was an interruption. You may notice some new lighting. Anyways, so this is where we left off the question, right? So well, this is what we have to do, and we have to find the smallest and the largest biggest solution to this equation. So in x plus 2 to the power of 16 minus 2 is equal to 0. Move 2 to the other side, x plus 2 to the power of 16 equal to 2. Now because 16 is an even number, therefore x plus 2 can only be plus minus the 16th root of 2. So we move that to the other side. So minus 2 plus minus the 16th root of 2. And I think it's easy enough to see that these are the only two values, because see, if like inside you plug in a negative, then you're gonna get a complex value, and we're only looking for real values. So yeah, solving this one, we get that. Okay, let's write it in the notation that I wrote them here. So f4 x sub l is equal to, that's the largest value of L, the maximum value if you prefer that, 2 to the 1 upon 16 minus 2, and f4 x s is the smallest value of this polynomial, smallest solution of this polynomial, I should say, right? And that's how I wrote that here. So f4x sub z s, now we'll write that as 2 to the minus 2 to the 1 upon 16 minus 2, right? So well, r is not that tough to calculate from here. So we get 2 to the 1 upon 16 minus 2 minus 2 to the 1 upon 16 minus 2. Now notice that this and this cancel out, right? And this becomes the 2 times 2 to the 1 upon 16, and by exponent rule this is like 2 to the 1, so there's a 2 to the 16 upon 16, 2 to the 1 upon 16, and then by exponent rule, if it's like a to the b times a to the c, this is equal to a to the b plus c. So adding those, 2 to the 17 upon 16, that's our value for r. That's pretty much the question is done at this point. I mean, comparing, we have our values, right? 2 is not a perfect square, so it's square free. Then p and q are co-prime, 17 and 16 are quite clearly co-prime because one of them is prime. So anyways, that's pretty much the question done. And so from here, a is 2, p is, well, p was the numerator of our exponent, so 17, q is the denominator of our index, so that's 16. So a plus p plus q. Yes, now this is the hardest part of the question, honestly. So it's 2 plus 17 plus 16, and this is a monstrosity to calculate, like, so that's like, okay, that's 18 plus 17. So 18 plus 17, that's 18 plus 18 minus 1, right? So from here to here, right? Yeah, so that's 36 minus 1, 35. Boy, that was tough. Anyways, yeah, that's pretty good. Nice.